Okay, to simplify this one, I would write 45 as 9 times 5. And, well, we could write, anyway, times z to the 45th is okay here. So the square root of all that, and then there's a property of radicals that the square root of a times b, remember the square root of a times b equals the square root of a times the square root of b. So we can split this radical up as the square root of 9 times the square root of 5 times the square root of z to the 45th power. And then we have a couple things here. The square root of 9 is 3 squared. And recall that the square root of a squared is a, when a is positive, anyway. So this is equal to 3 radical 5. And now for the z to the 45th, let's divide the exponent by this invisible 2 that's always outside of a square root. So we're dividing 2 divided into 45. 2 divides into 45. Well, 2 divides into 4 twice. 2 times 2 is 4. 4 minus 4 is 0, so you bring down the next digit, 5. 2 goes into 5 twice. 2 times 2 is 4. And then 5 minus 4 is a remainder of 1. The remainder is what we, well, one of the things we want. The quotient is how many z's escaped. So 22 z's escaped the radical, and 1 z remains under the radical because the remainder was 1. And again, this 22, the quotient tells you the exponent of the z, how many z factors escaped, and the 1 tells you how many z's remain under the radical. So putting this all together, we have 3z to the 22nd power, and the square root of 5 times the square root of z can be put together as the square root of 5z, because after all, the product of radicals is the radical of the products. So that's how this expression simplifies.